All right, so big show start. And so I will first do this 5 minutes presentation to calm you down. And so you will one by one be great. But this definitely help you for your final report. This is just 10% of your final class grade, right? 40% are your final report. So that's why you want to be critical so you can get more feedback to improve your final report. Okay, so let me get started. I'll give you a brief introduction what I'm doing in my lab, what we are doing in my lab. So my lab is especially computer-aided drug design, and our goal is especially replace the traditional approach for the drug discovery, which will take so long, so much money. Okay, and how we can accomplish that? We want to use the information on the drug target. We know it's a sequence. We know it's a structure. We have the physical understanding how the drug interacting with the drug target. We have all those information, so we use those information to do the virtual screening. And from virtual screening, we can got short list. So out of the billions compounds, we can got 5 or 10 compounds. And then we can pass that to the wet lab for the testing. Okay, so besides that structure-based virtual screening, in my lab, we have some special tools, which are molecular dynamic simulation. What's molecular dynamic simulation? Here, I show you what we're doing. Use the physical model to simulate it, the biophysical process of the biomolecular process. So in this case, it's a folding. The green one is experimental structure. We basically start from the sequence. One sequence can fold into the native structure. Okay, so you see now it's folded. So with those tools, we also can study how the drug interacting with drug target. So in this case, it's a cancer drug. This is still the first lung cancer drug. And so we can simulate its bonding process. Okay. So it start with the base pairing and opening and insertion. This is Chinese version, Julia, Rumia, and you kind of see the interaction. So in the real bonding, there's a lot of interaction. So it's not a simple process. Okay, so for that, we have access to the fatty supercomputer to simulate those process and use those information to help us to pick the compound. So then with that one, so now through this class, you learn all the technique we have used. So then we do the anti-COVID-19 drug development, we do the cancer drug development, and we even do the receptor design. And this is actually the simulation about the T-cell memory receptor. So we want to design the receptor for curing the cancer. Okay, so that's kind of big kind of dream. Okay, and also doing the drug discovery for the neuron disorder. So here you can see the signaling. So those are the memory receptors. So when the ligand signal bond, and then response is the nucleotide basically we're releasing. Okay, that's G protein coupled receptor. So we use a simulation to get active conformation and use active conformation to do the drug kind of search. Okay, so this is a try to understanding how the ionic liquid can stabilize the enzyme. Hopefully we can improve the enzyme activity. This is collaborated with the Dr. Vaden and Dr. Caputo. Okay, so those are what kind of doing. And then, okay, so poster. So in the CSM research day, my group basically has 9 or 8 posters there. You probably see some of them. Okay, you see some of them. And so here's the publication. So Lily, every year we have over the 10 publication. Lily, every research student in my lab has a publication. Okay, even for high school students. Okay, and I want to say this is that I know some of you want to pursue the graduate study, and so now within the chemistry we have the pharmaceutical science program and have the MS PhD program, and in the biology we have the bioinformatics program, and also we start the complex biology master degree and the PhD degree. Okay, so if you consider that way, okay, then what's the other thing? Award. So this is just the University Research Breakthrough Award, and which basically to recognize our contribution on the evolution theory development based on the SARS-CoV-2 data. And I think Teddy read that paper. And many of the party read that paper, particularly in the other class. And so this is the award from the Supercomputer Center offer us to tackle, design the next generation of the T-cell receptor. So you see everyone smile, happy, and in the lab. Not true. Okay, so this is the Masaling, and actually graduating friend, and so she actually will start his learning in the SOM. Okay, and so here organic synthesize, and Candy. Okay, so Candy, she's heading for the PhD MD. Okay, that's the Dean's Distinguished Senior Award. And then Nick, you know the Nick. So Nick basically won the post award in the Middle Atlantic Bioinformatics Conference, which literally you have the group from the Harvard, you have group from UPenn, you have group from Stanford, you have group from Oliver, and he won the training post award. Okay, and we also have the high school God award. That's my presentation.